So here with us there is an interesting circuit and its input output waveforms. So this circuit is used to shift the level of the voltages. It's called as voltage shifter. So as you can see, we'll see how it shifts the voltage. This is the input voltage that needs to be shifted. Here is your Zener diode, and we have seen in earlier modules how Zener works, how its operation, what is its input output characteristics or current voltage characteristics. And with that knowledge we are going to analyze this circuit. Here is your resistor R, and across which you have an output voltage. So the circuit works like this. You have an input voltage with positive applied to the cathode of the Zener, and this is an anode of the Zener. So as long as your applied input voltage is smaller than the VZ Zener voltage or the breakdown voltage of the Zener diode, your diode is switched off and the output voltage is 0. As soon as your Vin voltage exceeds the Vz of the Zener diode turns on in a reverse bias, lets the current flow from cathode to anode and subsequently through the resistor R, and then output is ready to follow the input voltage. So you keep on increasing the input voltage, there is a more and more current that will flow through the diode and through the resistor R, and accordingly the voltage drop across R, which is nothing but V output, will also go on increasing. So this is basically a voltage shifter. You have an input voltage and you have an output voltage, and two voltages are different. Whatever you apply here as an input, your output is different. It is different and it is lower than the input voltage by the Zener diode voltage Vz. So output here, by applying the KVL here, we see that Vin minus Vz minus I times R is equal to 0, or I times R, which is nothing but V out, is equal to Vin minus Vz. So remember, V out will always be Vin minus Vz. So it will be less than the input voltage, and that voltage is the Vz. So here is the output waveform. We can see that on y-axis you have a voltage and x-axis is your time. So this dotted curve tells us how the input voltage is slowly increasing linearly with respect to time, and it starts from 0 and it goes on increasing in this way as long as it is less than Vz voltage. Here is the Vz point. Your output is the dark curve, that is 0. But as soon as your input voltage is greater than Vz, your output is then Vin minus Vz. So here is that difference and the level shifting of the voltage. So this is 1 Vz drop less than the input. Your output will be Vz drop less than the Vin voltage. So if your Vin voltage is 5 volt and Vz is 2 volt, the output will be 5 minus 2, 3 volt. So this is how this circuit is helping us to shift the voltage level of the input signal through the Zener. Now exercise for you, just reverse the position of the diode and tell me how the Zener will operate, and draw the voltage versus time, where you show me the relationship between V in and V out, and the Zener voltage value, you can take it. So hope you understand this concept of voltage shifting. If you did so, like and share this video with others. Subscribe to the channel and stay tuned for more technical rich content. Till then, wish you happy learning.